Hi guys, today's lesson is on measuring and constructing segments. This is part one of a two-part lesson. And if you notice up here for our objectives, the thing we're going to focus on in this lesson is on finding length. Okay, finding the length of segments. Because remember, segments can be measured. So that brings us to our first postulate. If you remember from our previous lesson, a postulate is one of our common sense type rules of geometry. They don't need any proof. All postulates are accepted without proof. So if you take a look at this ruler postulate, it says the points on a line can be put into a one-to-one correspondence with real numbers. Now that's a lot. Basically what that's saying is that each point matches with a number on a number line. So if you look here, you have point A matching with -1. B matches with 0, C with 1, and so on. So it just means that your points are going to match with numbers. And if you take a look at this number line down in here, you can see the letters are the points, the numbers are the coordinates. Okay, we call the numbers the coordinates and the letters are the points. All right, let's talk about distance. Distance between 2 points. Now, if I wanted to find out how far it is from J to K, what would we do? What would you do? You would simply probably just count the spaces, right? You would just say, okay, that's 1 space, 2, 3, 4, 5, 6, 7. 7 spaces. So that means the distance from H to K is 7 units long. Now that works great if the numbers are close together. But if the numbers are not close together, let's say instead of -2 there, that was actually -281. And let's say this 5 was 572. That's a big far gap. You would definitely not want to start counting spaces between those numbers. So you have to have another way to do it. And the other way that we can do it is to find distance between 2 points. You can take the absolute value of the difference. You subtract between the coordinates, the difference between the coordinates. So the difference means subtract. So if I'm trying to find the length of HK, right, the distance between H and K, I can simply take the -2, subtract the 5. So -2 minus 5 is, of course, -7. Take the absolute value, and you get 7. Because you have to do the absolute value because all distance, length, they're always positive. You can't have a negative length or a negative distance. Now, I used the -2 first when I subtracted, but it honestly doesn't matter. I can simply just do 5, take the bigger number of 5 minus the -2. 5 minus -2 would be +7, which again, the absolute value of +7 would be 7. So either way you do that, you're going to get the exact same answer. And as I said before, if the numbers are close together, you can simply just count them. But when they're not close together and they're big numbers, that's when you need this method to be able to figure out that length or that distance. So the distance between any 2 points is the absolute value it's the absolute value of the segment that connects them. All right, so let's take a look and find the distance between E and J. So again, as I said before, we could just count it, but let's use our ruler postulate to figure this out. And actually, it's not the ruler postulate, it's actually just a way of calculating distance. The ruler postulate is the fact that the letter there matches with the number. Okay, so let's find that distance or that length between E and J. So E is at 1, J is at 7. So I can do either the 1 minus the 7, again, taking the absolute value, which would be 6, or you could simply do the bigger number 1 minus 7, which would be 6, and then take the absolute value of 6, which is just 6, +6. Remember, all length or distance would be positive. Okay, now let's just remember a couple things about the length of a segment. The length of a segment is basically the distance between 2 points. It is the measure. It is the actual measurement, okay, of the segment. It is always positive, and it is named by 2 capital letters. Okay, it's always named by 2 capital letters. Now, we have lines named with 2 capital letters, and we have segments named with 2 capital letters, but length is also going to be named with 2 capital letters. However, there is no symbol on top. And remember, those 2 capital letters are going to be your endpoints. So if I have EJ, if you noticed here, I didn't put any symbol on top. That symbol states that there is no symbol on top, as you can see, which means that that stands for length. That's what we know. We know that that is going to be length. Okay, so when you have no symbol on top. So that's important. Okay, so no symbol on top. Very important. Okay, let's take a look at some of these problems down below. We're going to find the length from E to J. And once again, you could count this, but we're going to use our distance rule to be able to figure that out here. So let's take the absolute value. If you want to take the bigger number at G, which is 5, minus the smaller number, that's fine. 5 minus 1 is 4, so the absolute value of 4 is 4. We want to find EF. Now, F is going to be a decimal. That's 2.5. So we're going to take 2.5 minus 1, and you, of course, get 1.5. So the absolute value of 1.5 is just 1.5. And I simply already worked out the last one here for you, finding the length from F to H. F is at 2.5 and H is at 5.5. And again, as I said before, you can take the bigger number minus the smaller number or the smaller number minus the bigger number. It doesn't matter because you're going to do the absolute value. In this particular case, you would get -3, which the absolute value of -3 is 3. Okay? All right, now we're going to get into one of the most important postulates in our geometry book that we are going to use a lot, and it is the segment addition postulate. You know, this particular postulate is kind of common sense. And again, remember I said postulates are common sense. So it's going to come across as a very like, oh, yeah, that makes sense. But if you take a look at it, we're going to use this quite a bit. And basically what it says is if you have a point between two other points, then what you can do is add your two little segments together. So I can take this segment AB, and I can add that to this segment BC, and what will that equal? That will equal the entire whole segment. The whole big segment it will equal. And of course, then you would end up with the whole thing AC. Okay? So AB plus BC is equal to AC. Little segment plus little segment equals big segment. This is the way that I want you to remember it. Okay? The little plus the little equals the big. Now, let's take a look at this example here. They're telling us that point Q is between P and R. So it has to be between. You can't have it anywhere else. In order for this to work, one point has to be in between the other two. So what this is saying here is if P to R is 16, how do we find QR? Well, we set it up. You always want to set it up and write out the segment addition postulate for every problem. That's super important. PQ plus QR is equal to PR. So the 9 plus the X is equal to the entire thing, which is 16. So again, then you're just solving the algebra. You're going to subtract 9 on both sides, and of course you get 7 for the length of QR. All right, let's look at the next problem here. And again, I want you to set up your segment addition postulate. So DE plus EF is equal to DF. Okay, so we set it up. That's our segment addition postulate. So we're going to take the 90, which is our DE, plus the 45, and that is equal to DF, which is X. And of course, that's an easy one because you can simply add the 90 and the 45 together, and you get 135. So now we just found X. You always want to double check. X may or may not be your answer. They're asking you to find DF. Well, DF is our X. So we're in good shape. The length of DF there is going to be 135. Okay? Let's look at the next one over here. I already set up the segment addition postulate for you. AB plus BC is equal to AC, the whole thing, right? Little plus little is equal to the big. So we have 8 for AB, we have Z for BC, and then the whole entire segment AC is 14. So we're going to do the algebra. We're going to have to subtract 8 on both sides, and when we do that, we get Z to equal 6. Now, we got to double check. Z is 6, right? Just like over here, we had X is 135. Let's plug it back in. Well, BC is 6, right? That is our Z there, so that will be 6. So we can put that answer in there. That doesn't always happen. Sometimes you have to substitute. So you have to be careful. Let's look at the next two. In this particular problem, we're going to set it up. JK plus KL is equal to JL. Again, that's our segment addition postulate. So JK is Y, KL is 5, and our JL is 7. Okay, so we just have to simply solve, subtract 5 on both sides, and our y value is equal to 2. Now, double check. We have to find jk. Well, that happens to be the y value, so that is going to be 2. All right, so the next one. We've got to find xy. So I plugged in my segment addition postulate. wx plus xy is equal to wy. Right? So a, this part here, plus a plus 6, this part here, is equal to the whole thing of 36. Now, we've got to combine like terms here. A plus a, 2a plus 6 is equal to 36. Subtract 6 on both sides, we're left with 30. 2a is equal to 30. We have to divide by 2, and a works out to be 15. Now, that's our a value. We have to find xy. xy is a plus 6. So you have to be careful on this one. You're going to have to substitute. xy is equal to the a plus 6. So we have to plug in that a of 15 plus 6, and we come up with our answer of 21. So be very careful with that one because you have to plug in. Even though we got our a to be 15, that wasn't our final answer. We had to substitute in to find that final answer, that length of xy. All right, last two. All right, in this one here, we've got segment addition. ST plus TV is equal to SV. Again, you want to set up your segment addition postulate. So ST is 20 plus TV is N, and SV is 2N minus 1. All right, so let's simplify here. Let's solve things. All right, so what do we want to do? Well, let's subtract N on both sides. So we get 2N minus 1N is just N, and that cancels out. So we have 20 is equal to N minus 1. Left, add 1 to both sides, so we end up with 21 is equal to n. So the n value is 21 there. Now, we had to find for this problem SV. So SV now is equal to the entire thing of 2n minus 1. So we're going to need to substitute for this. We're going to plug this in over here. So the length of SV is going to be 2 times 21 minus 1. So 2 times 21 is, of course, 42. Minus 1 is 41. So the length of SV there is 41. And that's our final answer. All right, last problem. Again, we're setting it up with the segment addition postulate. ST plus TU is equal to SU. ST is Y, TU is 18, and SU is 2Y minus 4. All right, so let's combine like terms. Let's see here. We want to move the Y over. So 2y minus 1y leaves us with y. So 18 is equal to y minus 4. I'm going to add 4 to both sides. And when we do that, our y works out to be 22. So that's our y value, but we have to find st. Now st here is the y. That is our y. So we are lucky on that one. We don't really have to do much substituting there. St is 22. Okay, if there's any part of this lesson you didn't understand, go back and rewatch. Good luck.